Okay, we want to find out if this series is convergent or divergent. So we can use the alternating series test for this one. So we have b sub n right here in the denominator, so we can isolate that as 1 over 3 plus 5n equals b sub n, because this is the alternating part, and that would be considered a sub n. With these alternating series, you split it into two so you can see it more clearly. Now that we have b sub n, we need to bring into the game b sub n plus 1. So b sub n plus 1 would be 3 plus 5 times n plus 1, which would equal 5n plus 8. 5n plus 8 there in that denominator. So now we have to make sure that b sub n plus 1 is less than or equal to b sub n. And we know that it is because it's going to have a larger denominator, as we can see. It has a larger denominator, and therefore the term as a whole becomes smaller than b sub n. And that's what we need for this. So in order to know if this series converges with the alternating series test, we make sure that b sub n plus 1 is less than or equal to, and in this case it is less than. So we have b sub n plus 1 being less than or equal to b sub n. So that's our first condition met for convergence. The second condition we need to meet is that if we take the limit as n approaches infinity of this, that equals 0. So let's try that. Limit as n approaches infinity of 1 over 3 plus 5n. And yes, if we plug in infinity into that, this is going to give us an infinite denominator, which means that the 1 up there gets reduced to 0. So yeah, we do have 0. So it meets both of our conditions. B sub n plus 1 is less than or equal to b sub n, and the limit as n approaches infinity of b sub n goes to 0, so therefore this converges.